This video is for your subject Science and Technology, Paper 1. In this video, we are going to study the Chapter 1, that is Laws of Motion.
Students, in the previous video, we have studied about distance. Distance, according to definition, is the actual length traveled by an object while traveling from point A to point B. Now, keeping that into consideration, we will move further in our topic. Now, everyone must have seen a 100-meter race during the heats, and most of you must have participated also. According to the race, you have got a starting point and a finishing point. The participants start the race at the starting point and reach the finishing point. Everyone travels the distance of 100 meters. They travel the distance of 100 meters. Everyone is traveling the distance of 100 meters. But still, only a few get selected. Only a few get selected. How? They get selected based on who has reached the fastest. For example, consider we have three participants, P1, P2 and P3. These three participants start from the starting position and reach the finishing line. The first player or the first participant reaches in 10 seconds. The second one reaches in 12 seconds and the third one reaches in 13 seconds. Okay, now based on these results, you can easily tell that the participant 1 has reached first, participant 2 has reached second, and the participant third has reached third. Okay, now how can you tell that they have reached first, second or third? By looking at the time taken by each of them to cover this distance of 100 meters. So the person who has covered that distance in the less amount of time is the person who has reached the fastest, and the person who has covered the distance in the maximum amount of time has reached slowest. So this fastest and the slowest, these concepts are related to speed. So when an object travels some distance or covers some distance in some unit time or in per unit time, then that distance covered in that unit time is called as speed. The speed can be defined as the distance covered by an object in per unit time. The mathematical formula of speed is distance covered upon time. Distance covered upon time, and the unit for speed is meters per second or centimeters per second. Meters per second and centimeters per second. Now consider this race. We'll just continue with this example of race. Consider in this race, I tell you one thing, they are running 100 meters at some speed. But I tell you that the race, the starting point and the finishing point, it is in the direction of east. It is in the direction of east, means these students are running 100 meters towards east direction, towards east. So I have added a direction. I have added a direction. Now when you add direction to speed, it becomes a vector quantity. And speed with direction is called as velocity. Speed with direction is called as velocity. So velocity is, here speed is distance upon time, velocity is displacement occurred per unit time. Velocity is displacement occurred in per unit time. Okay, and the unit for velocity is again meters per second or centimeters per second. Students, velocity and speed, they're connected. Velocity is nothing but speed with direction. Okay?
Let us now look into the difference between speed and velocity. Speed is the distance traveled per unit time. Velocity is the displacement occurred per unit time. Speed is a scalar quantity. Velocity is a vector quantity. Speed is always positive. Velocity can be positive or negative depending on the point of reference. Speed cannot be zero for a distance covered. Velocity is zero for zero displacement. The unit of speed is meters per second. The unit of velocity is meters per second. Students, we will now look into the effect of speed and direction on velocity. Now, as you can understand that speed and velocity are the same things. The only difference between speed and velocity is that speed does not need direction, but velocity requires direction. Now, speed and direction can have an effect on the velocity of the object in motion. So, the velocity changes due to the following reason. If the change in speed while keeping the direction same. Now, since velocity is nothing but speed with direction, so if you change the speed of the vehicle, then there is an obvious change in the velocity of the vehicle. Velocity changes to changing the direction while keeping the speed constant. Now students, velocity is speed with direction. Now if you keep the speed constant and change the direction, obviously there will be a change in the velocity. And changing the speed as well as direction. So students, if you change the speed and the direction of the object in motion, the velocity will also change.
Students, you all must be knowing about accelerator in a vehicle. Now, what is the work of accelerator? The accelerator increases the speed of the vehicle. Consider this situation where on a vehicle is moving on the road. Consider the vehicle at point A. At point A, consider the velocity of that vehicle is say 30 meters per second. Okay, and the vehicle is moving in this direction. And when it reaches this point, its velocity becomes say 40 meters per second. Okay, at point B, the velocity becomes 40 meters per second. So what has happened over here is that the velocity has increased. Say it has taken 5 seconds for this vehicle to reach from point A to point B. Okay, so the velocity has changed after 5 seconds from 30 meters per second to 40 meters per second. Students, this change of velocity in unit time, this change of velocity in unit time is called as acceleration. Is called as acceleration. So what is acceleration? Acceleration is the rate of change of velocity in unit time. Okay, the mathematical formula for acceleration is acceleration A is velocity or the change in velocity or the change in velocity upon time. Change in velocity upon time. Now, change in velocity. When you say change in velocity, which means there has to be two velocities, one velocity at the beginning and one velocity at the end. The velocity at the start is called as the initial velocity. Initial velocity. And the velocity at the end is called as final velocity. Understood? Now, how do you calculate the change in the velocity? The change in the velocity is calculated by finding the difference between the final velocity and the initial velocity. So, acceleration A is equals to V minus U upon T. V minus U upon T. Now, you understand I have put in a dash over A, V and U. This A, V and U are vector quantities. Hence, I have put a dash over there. Now, over here, A means acceleration. V is the final velocity and U is the initial velocity and T is the time taken for that change in velocity. So acceleration is the change in velocity upon time. Students, acceleration is of three types: positive, negative and zero acceleration. Okay, now we'll look into each acceleration one by one. So the first one is positive acceleration. Now, positive acceleration, we'll look into an example. Consider you are sitting in a train which is halted at a station. When the train leaves the station, the speed of the train increases, which means the train is gaining some speed or the velocity is increasing. Now here, when you calculate the acceleration, the initial velocity is 0 and the final velocity will be obviously greater than 0 when the train leaves the station. So when there is an increase in the speed of the object, when there is an increase in the speed of the object, then you say that the acceleration is positive. On simple terms, if the final velocity if the final velocity is greater than initial velocity, then you say there is a positive acceleration. So in positive acceleration, the speed of the object increases or the velocity of the object increases. Now what will be negative acceleration? Negative acceleration will be opposite of positive. What happens when the train enters the station? It is moving at some speed and then when it enters the station, it comes to a halt. Okay, it stops. So the velocity becomes 0. Before entering the station, the velocity of the train was greater than when it entered the station or when it came to a halt. Understanding? So when there is negative acceleration, the speed of the object or the velocity of the object decreases. Okay, so in negative acceleration, the final velocity is less than the initial velocity. The final velocity is less than the initial velocity. Now, there is something called as zero acceleration. There is something called as zero acceleration. Now, what do you mean by zero acceleration? Zero acceleration is where there is no increase in the speed or the velocity of the object. Means if the object is traveling at constant speed, it is traveling at constant speed. So there is no increase or decrease in the velocity. At that time, what happens is that, for example, consider this example. If from point A to point B, the vehicle has moved, and if at point A the velocity is 30 meters, and at point B it is again 30 meters per second. See, it is moving at some speed, but has the velocity increased or decreased? No, it hasn't increased nor has it decreased. So there is no acceleration over here, or there is zero acceleration. So what happens over here in zero acceleration? The final velocity is equal to initial velocity. So in zero acceleration, the final velocity is equal to the initial velocity. Understood, students? Acceleration are of three types: positive acceleration, negative acceleration, and zero acceleration. In positive acceleration, the final velocity is greater than the initial velocity. In negative acceleration, the final velocity is less than the initial velocity, and in zero acceleration, the final velocity is equal to initial velocity.